I'm meteorologist Adam Epstein. Welcome to another installment of Weather Club Wednesday. This is episode 7, and today we're going to be going over the topic of climate. So when it comes to meteorology, there are two branches. Meteorology is the study of both weather and climate. So they're separate but very related things, and we're going to focus on what exactly the differences are to start. So when it comes to weather, this is your mood, how you feel at a certain point in time. Meanwhile, climate can be thought of as your personality. How are you overall as a person? So here are some examples. This is a temporary or a specific location. That's what weather is. And when it comes to climate, it's conditions for a region for a longer period of time. Think of that mood versus personality mindset. This is a day-by-day thing for weather. For climate, it's 30 years or more. When it comes to weather, it's your forecast. Climate is your averages and normals over a period of time. Weather is what you get, and climate is what you expect. Now, here are the examples I wanted to get to. So if you have a heat wave in the forecast for this week, that is weather. That's a singular event. But when you say it's the warmest month on record in California, that is a climate event. Now, when you say a rainstorm is expected this weekend, once again, remember that's a forecast. If you're talking about rain and the fact that each wet season has more rain than the last, that changes over a long period of time. That's climate. If you say it'll be 65 degrees on the 4th of July, which should be a warm day, this is pretty cool, well, that's weather. If you say the normal high for the 4th of July is 90 degrees, that's climate. Remember, normals and averages. Now, there is an exception. If you hit a daily record high or low or rainfall, that is considered climate. So if tomorrow you hit 100 degrees and that's a record, even though it's a single day, that would be climate. And when it comes to our atmosphere, this is what dictates, this is what controls a lot of our climate. The air that we breathe, you might be surprised by this, is not mostly oxygen. It's actually just 21% oxygen. Most of the air we breathe is nitrogen, and then there's 0.9% argon and some trace gases. And one of those trace gases is carbon dioxide. Only 0.04% of our atmosphere, but it has a much larger impact than it looks like. So there's something called the greenhouse effect. So this is when you have solar heat come from the sun, go through our atmosphere, and some of it is absorbed, some of it bounces back up towards space, and some of it gets absorbed by greenhouse gases and reflected in all directions. So one of those greenhouse gases is carbon dioxide. Another major contributor is water vapor. So without this, you'd have heat from the sun come to Earth and leave, and it would be too cold. We couldn't live here. But thanks to these greenhouse gases, we're able to trap some of that heat back in our atmosphere and keep it warm enough so we can live. However, if you have too much of something, that could be a bad thing. So this is what a carbon dioxide molecule looks like. It's composed of one carbon atom and two oxygen atoms. They're connected. So that's some chemistry for you. So this traps heat radiating away from the Earth, which is a very important process. Remember, just 0.04% of the atmosphere, but the amount matters way more than the percentage does. So in 1750, a while ago, it was considered at 280 parts per million. That's how we measure these molecules in the atmosphere, how many parts per million. So 280. That's when the Industrial Revolution started. Then in 1920, it was 300 parts per million. Now, it's 2020, and we're at 400 parts per million. So you notice that number is going up and up and up. So this is the change in our atmosphere from these greenhouse gases and carbon dioxide. Notice the past 800,000 years, never did it get over 300 parts per million. And then in the recent history, we had a few events that has caused this to skyrocket. So you can see the massive differences here. It seems like it doesn't really fit. Well, why is it increasing? That's a great question. I have this one. You probably have it at home too. Why, over 800,000 years, has it never been as high as it is today? Well, there are a few reasons for it. One could be a natural reason. Tiny wobbles in the Earth's axis. So the Earth tilts towards the sun, tilts away from the sun. These small differences can lead to extra sunlight, which leads to extra warmth, and that can take carbon dioxide out of the ocean and put it into the atmosphere. That happens on a natural scale. But this doesn't look like a natural event. You saw that graph shoot all the way up. So with it never exceeding 300 parts per million in the past million years, you can base this on thick ice cores. So what an ice core is literally a tube of ice that you drill for. And in those ice cores, there are bubbles of air, and you can measure the amount of carbon dioxide in those bubbles of air. So you think of a mile-long one, that tells you a lot about previous history. So this can go up to 1 million years back. So we go forward, and why is it going up? Well, the difference is we've been burning fossil fuels like gas, petroleum, and coal. And that adds carbon dioxide to the atmosphere at a rate we haven't done before. So this graph shows you, in the pink line, the atmospheric carbon dioxide, what we've been talking about. The blue line shows our human carbon dioxide emissions. Notice, atmospheric carbon dioxide starts going up as our emissions of carbon dioxide start going up. So it's no coincidence that both of them are going up at the same time. So with our carbon dioxide going up, this impacts our water vapor, which you recall is another greenhouse gas. So water vapor, you can think of clouds in the sky. That's part of water vapor. So it fluctuates frequently, its weather, between 0 and 4% in the atmosphere. When carbon dioxide increases, water temperatures increases because it increases the temperature of our air and water. The water vapor then increases, and since water vapor is a greenhouse gas, that increases the value of that, and it increases warming. So you have this positive feedback loop where they're both not making a positive impact, but impacting each other in a rising way. So there's no way to control water vapor. We can't control the weather. We can't control how many clouds are in the sky, but we can control carbon dioxide. And that's the important thing to take note of. So the temperature has been rising as carbon dioxide levels have been rising. It's what you'd expect because it's a greenhouse gas and it traps more heat. So the bottom of the graph shows the year from 1880 over to 2019. And the temperature is going up and down by the seasons, winter, summer, but overall it's going up, and this is the carbon dioxide levels that are going up with it. So the next week's topic is going to be the impacts of the warming climate on our planet. What does this mean for us? How does carbon dioxide impact the oceans? How does it impact our weather? And how does it impact everyone living on this planet, including us and other animals? So I'm on air Monday through Friday mornings, 4:30 to 10 a.m. I love doing Weather Club Wednesdays, so I try to teach on air as much as I can. And it looks like next week is going to be the final installment for now. So I hope you learned something about climate, and we'll continue to learn next week. I'll see you then.